Right, so we have the question one here, and this is the 2017 module. Figure one is a diagram of a transformer. Name the parts labeled X, Y, and Z. So I will run through this one with you. So here we have the primary side, so this side would be the secondary side. Right, they want to know what is X. Well, X will be the AC power source, the AC power source. Um, Y, well, if this side here is the primary coil, then Y should be the secondary coil. Right? In this case, the secondary coil looking like it have more turns than the primary, right? Um, Z, that will be known as the soft iron core. So soft iron core. So that is how you label it. Sometime, I believe in the 2025, I can't remember which year, they would have asked to draw a transformer and label it. Right? But here they already give you the transformer drawing and they just want you to label it. So knowing how to draw and label a transformer is very important, right? Understand the solution here, right? So we're going on now to the next part. They say the transformer shown in figure 1 was tested and the values for the primary voltage Vp and the secondary voltage Vs were obtained. The data is shown in table 1 below. So you have values for primary and secondary voltage. So you have Vp and you have Vs. So using the grid on page 7, plot a graph of Vs against Vp. When you say to plot a graph of Vs versus Vp, on your y-axis you should have Vs, and on the x-axis you should have Vp. Because Vs is stated first and Vp is stated second. Generally, that is how it does go, right? What is stated first in the question does go first on the y, or whatever I stated second is go on the x. Right? Looking at this, you should, for a voltage, a Vs versus Vp graph, you should get a straight line to the origin, right? Um, so the way to plot that. So I already have it plotted here already, over here, right? So we have what CXC does look for is labeling the axes. So you have to label the axis, the y-axis with the proper title. This is secondary voltage Vs and the unit is volts. Label the x-axis. This is primary voltage Vp and the unit is volts V. This is the x-axis, so you should they should have x-axis there, and you wanna draw your axis for the y as well. Although it is not written, it is not drawn in this one. You need to put in that. What you just get marks for as well is the title, right? So you want to put a title for your graph. So the title for this graph will be, I could write back the same thing here. Graph of Vs versus Vp. You should put the unit and what they mean as well, but because of the space, I just put Vs versus Vp, right? This would be the scale. You want to put the scale directly under the title. So x-axis, every 2 centimeters represent 1 volt, and on the y-axis, every 1 centimeter represent 5 volts. Now, they wouldn't really check that, they would check the actual graph. So this is 1, 2 centimeters on the x-axis, that represent 1 volt, right? So they will check that. On the y-axis, 1 cm represent 5 volts, so they will check that, right? So that's important to note. Um, Now let's see if the points are plotted correctly. So remember that this should be on your y and this should be on your x. So we're looking for 1.5 and 14. So 1.5 will be in between 1 and 2. So this is 1.5. and 14 would be, well, in this case, if 5 if 1 cm is 5 volts, then one little block here would represent 1 volt because there are 5 little blocks going up to give you 1 cm. 5 little blocks makes 1 cm. So 1 little block is 1 volt. 5 little blocks makes 5 volts, I should say. Right? So 1 little block should be 1 volt. So this is 1 little block below the 15. So this should be 14. Right? So this is 1.5, 14. That is correct. The other one is, this is 326. This is correct. This one is 545. This is correct. This one is 6, 51, 52, 53. That is correct. Next one is, well, this is in between 7 and 8. So this is 7.5, 66, 67. This is 8, 71, 72. 8, 72. So all of these points are plotted correctly on this graph. And you draw a best fit line on it. Well, in this case, nearly all the points are on the line, right? Well, this point is kind of off here, right? So the next part is they want you to find the gradient, which is S. So to get the gradient, you need to state the formula for the gradient. So the formula for the formula for the gradient of a straight line is y2 subtract y1 all over x2 subtract x1. So I would use this point here. If I read coming down, this is 0.5, and I read going across, that is 5. So my first point is 0.5 and 5. And the other one would be, we read coming down, this is 6.5, and you read going across. I go see is right here, we 2 blocks below. This is 56, 57, 58. So I will say is 58. Right? So the x is 6.5 and the y is 58 because it's just below 60. So we use these 2 points and we getting the gradient there now. We have to find the gradient. So the gradient S will be, well, I will call this one x1, y1. I will call this one x2, y2, and I would substitute it. So replacing y2 with 58, minus I'm going to replace y1 with 5. This is all over. I'm going to replace x2 with 6.5, and I'm going to replace x1 with 0.5. So I'm going to get S to be equal 58 minus 5 is 53 all over 6.5 minus 0.5 is basically 6. So my slope, which is the gradient, is 53 minus, well, 53 divided by 6. I'm getting 8.83. 2 decimal places. That is my answer for the gradient. Understand this, right? So we're moving on there now. So that is the gradient. That is the graph. So I have to remove this. Right, so the next part D here on the right hand side. We just concern about the gradient part here for now. So I have to zoom in on this. So this next part, let's say to use the gradient S to calculate the number of turns in the secondary coil NS, given that the number of turns in the primary coil NP is 85. So there's this formula sheet here. You want to scroll down until you reach um, equations for ideal transformers. Now they don't give you this in the exam, but I mean, if you're using this to do past paper questions or practice, just look in the formula sheet. After a couple of tries, you might be able to learn it quickly, right? So you have NP slash NS, that means NP divided by NS is equal to VP slash VS. That is VP divided by VS. So we're going to put that NP divided by NS, NP divided by NS, NP all over NS would be equal to VP over VS, VP all over VS. So what you're trying to solve for there now is what happens in the secondary NS. Um, Now what you could do, you could just invert this both sides, right? If you invert this to both sides, you just basically flip in both sides. You will get that NP NS, my bad, NS over NP, because you flip it, would be equal. You have to flip the right hand side as well. VS all over VP. Now there's a reason why I flipped it, because when you have plot your graph, right, you had VS versus VP, not so. So the gradient S would have been the change in y all over the change in x. In other words, S is equal to the change in y would be Vs, so it's really Vs all over the change in x, but what was on the x-axis? Vp. So Vs over Vp is actually S, but you got S to be 8.83. So this is really Vs over Vp is equal to 8.83. So I'm going to use that 8.83 here now. I'm replacing Vs over Vp with 8.83. So I have Ns over Np is equal to 8.83. Here across the Np, I gotta multiply the 8.83 by Np. So Ns is equal to 8.83 times Np. So this would be 8.83 multiplied by NP, but where's NP? NP is 85. So NS is equal 8.83 times 85. I am getting 700 and, well, it's a whole number, it could be 751 thirds. It's a whole number if I round it off, right? So 751 thirds. Understand the solution for this part, right? So the next part, part two, they say, well, you had to use your gradient, right? Because they say use S to calculate the current in the secondary coil, which is IS, if the current in the primary coil IP is 1.8. So what you're going to do here now is you're going to look at the formula sheet again, and you have a formula relating IP and IS and VP and VS. So you have VP, IP is equal to VS, IS. So you're going to use that formula. So VP, IP is equal to VS, IS. So, so what you're going to do here now is characterize the VP. So you're going to get IP is equal to VS all over VP times the IS. I'm going to put this in brackets so you can see the substitution better. We already know that VS over VP is 8.83. So we're going to get IP. Well, I'll put in what is IP there one time. IP is IP is 1.8. Sorry, replacing IP with 1.8. 1.8 is equal to Vs over Vp, which is 8.83 times Is. To solve for Is, you just divide the 1.8 by the 8.83. So Is is equal 1.8 divided by 8.83, I am getting 0.2, approximately 0.2 ampere, right? And that is 3 marks. Now let's see the power output P out of the transformer given that the voltage in the secondary Vs is 55. So the power output is equal, we have the power formula here. Um, well, I have a formula related to power and current and voltage. Power is equal to IV, so P is equal to IV, but you want to use the, since you're dealing with output, you want to use the current in the secondary and the voltage in the secondary. So the power output would be equal to the current in the secondary was 0.2 multiplied by the voltage in the secondary, which is 55. So you're going to get power in the output is equal to zero point 0.2 times 55 is equal to 11. This is 11 watts. And that is my answer there. Understand this, right? Alright, so the question 2 is as follows. You have complete table 2 by inserting the appropriate physical quantities and derived SI unit. So they haven't brought this in a while. They didn't bring this in a while, right? So we have physical quantity, we have volume. So you derive SI unit. So think about a cube. If you were to measure the cube in terms of SI units, well, this looking like a cuboid. But let me say there's a cube, right? If you were to measure this in terms of SI units, the unit should be in terms of meters. So you find the area of the base, which will be meters squared. So volume is equal to area multiplied by height. So is the area, which will be meters squared, because side by side is m by m, which is meters squared, times the height, which is in terms of m. So m squared times m is m cubed. So you get the volume to be meters cubed. Um, Physical quantity. You have the derived SI units is kilogram per meter cube. So you write it like this: kg all over m to the power of 3. Because this is kg, m to the minus 3. So you're going to replace kg with m, you're going to replace meters cubed with v. So this is mass over volume. So this is known as density. So you have the derived SI unit is Newton. Well, we know Newton is the unit for force, right? We know unit of Newton, of force is Newton, right? Pressure. The derived unit for pressure is Pascal. Um, because you have, pressure is two formulas. Pressure in liquids is density by gravity by height. Also, you have pressure is equal to force all over area, which in this case for force over area will be newtons per meter squared. So those are the two units for pressure then. So you get with this table, right? Right. So the next part here now, they say the concrete block shown in figure 3 was made with cement. Concrete block was made with cement. Calculate the density. Well, one time you don't know that density is mass over volume. Calculate the density of the concrete block given that its mass is 20,160 kilogram. So density is equal to mass, which is 20,160 all over the volume. But we didn't get the volume yet. Now, this is tricky, eh? This is 4 marks to calculate density. This is tricky. Reason being is this is 140 centimeters. This is 2 meters and this is 3 meters. So the volume is the base area, which is the area, the bottom face. So is base area, and this is a formula we use in maths, right? Base area times the height of the shape. So volume is equal, the base area will be, you will have to convert 140 cm to centimeters by dividing by 100. 140 divided by 100 is 1.4 meters, right? Times 2 times the height of 3. So you're going to get a volume, density is mass of volume, right? 1.4 by 2 by 6. I think 16.8. And this will be meters cubed. So this is 16.8. So density is equal 20,160 divided by 16.8. I'm getting 1,200. This would be kilogram per meter cube because density is mass over volume. The unit for mass is kg, the unit for volume is meters cube. So kilogram per meter cube. Um, make sure that's correct. 20,160 divided by 16.8, 1,200. That's now my bad. Again, 8.4. So 1.4 times 2 times 3. Again, 8.4, not 16.8. I don't know how I get that just now. Probably type it in wrong in the calculator. So you see, it's always important to double check. So that means that this might be twice the value, right? So I'm getting 8.4, which is like half of the original volume that I get. So this is divided by 8.4. So 20,160 divided by 8.4, again 2,400. Yeah, I don't see any errors there now. So this is 2,400 kilogram per meter cube, which is the density. Understand the solution here, right? Right. Now the next part is to define the term pressure. Now pressure can be defined as a ratio of force and area, or force divided by area, or the force acted per unit area on a surface. Um, Pressure is defined as a force acting per unit area. So I'm going to have pressure is equal to F all over A. The SI unit is Pascal, or Newton per meter squared. Part 3, given that gravity is equal to 10, calculate the pressure exerted on the floor by the base of the concrete. So we know that pressure is equal to force all over area. Pressure in solids, that is, right? Um, the area of the bottom piece would be, this is, remember this was 1.4 meters, so it could be 1.4 times 2. The force is basically mass by gravity, because force in this case is really the weight. Since F is equal to W, F is equal to mg. Alright, so is the mass, which is 20,160 multiplied by 10, which is gravity, all over the area, which is 1.4 multiplied by 2. That is the area, the base, this shaded region here. Right, that will give me the pressure in terms of Newton per meter squared. So typing it in my calculator now, put in my bracket, so 20,160 times 10 close bracket divided by 1.4 times 2 close, open and close bracket, I get getting something around 72,000 Newton per meter square, or 7.2 multiplied by 10 to the power of 1, 2, 3, 4, 4 Pascal. Or you can put back the Newton per meter square, it don't really matter. But I just wrote my answer in standard form there, which we do sometimes in physics when dealing with large numbers. So you understand the solution here, right? Right.